Good morning, students. Today we're going to add just a little bit more information on our presentation from yesterday. And if you recall the Prezi that we saw yesterday to practice, I've added some more information for your benefit. Just as a review, remember that if an object is not moving, if the object does not move, no work is being done. I gave you the example yesterday. If you are holding a book over a table, you are not doing any work. You are simply exerting a force on that book so that that book does not fall down. But unless the book moves, no work is being done. I just want to review that with you. Some of you asked me yesterday how long ago or who invented simple machines, or how long have they been around? And simple machines have been around back on the days of Archimedes, back in 260 BC. The first documented levers were trees that were used to move heavy rocks from one place to another. And remember that a mechanical advantage is something good that occurs, or that you make happen with your own energy, with your own movement, from either using your hands or your feet. And as a review, if you recall from our past lectures, remember that when you're strumming a guitar, your fingers are causing sound energy to be produced. When you ride a bicycle, your bicycle can take you from point A to point B because you're pedaling with your feet. It's energy that you're putting in. It's mechanical energy. And to give you an example, or to use it in a sentence, we ride bicycles because of their mechanical advantages. I know that a lot of you would rather ride a bicycle to a certain location because it beats walking. Simple machines are one-step tools. They do not eliminate work. They simply make work easier. And today's lecture will cover levers, pulleys, wedges, screws, ramps, wheel, and axles. And how do these, after exploring our practice whisks, we found out, a lot of you had questions, how do these machines make work easier? And it's not that, once again, it's not that they eliminate work, it's the fact that they spread the effort, they spread the force. They are working with the force that you're putting in. Levers, for example, reduce the effort because they incorporate a fulcrum, okay? And the fulcrum, we'll see it in a little bit, it's the pivot point. Pulleys reduce friction, okay? Wedges, when you apply a force downward, the wedge, because of its pointy, its point, the force that you apply downward spreads your effort not only downward, but it spreads it in opposite directions. Screws are used for fastening, for tightening things together and fastening them, holding them together. Ramps, you must understand that the longer the ramp is, the easier the effort on your behalf. The wheel and axle, the axle, you'll see it in a few minutes, but the axle supports the load. And the wheel, because of its diameter, it amplifies your effort, okay? Here you can see a picture. This, once again, this is the fulcrum, that when you incorporate a fulcrum to a lever, it reduces the amount of effort you have to put in with your hands. The inclined plane, you have seen this. I talked about this yesterday. Anytime you're moving furniture, you will see that a furniture store will bring a furniture truck and they will unload a ramp first. And that's how they will bring your furniture down, okay? The inclined plane, the ramp. The wedge, you're seeing it backwards, but notice how an axe is an example of a wedge. And anytime you take a whack with the wax, this pointy or this point is making a way into a tree. If you're trying to create logs for your fireplace, you start breaking the tree, and this diameter right here from the wedge, the reason that it cracks the tree is because the more that you push downward, this particular diameter in the wedge is pushing that log outward, okay? The pulley, you pull on one side and you know that the load is being carried on the other side. And this particular, since it's a steel pulley, it has a groove in here that I'll show you in a bit. And this groove, it reduces friction. Okay, so it makes your pulling a lot easier. The screw, these are called pitches or threads, and they make fastening a lot, or they make fastening a lot tighter. Okay. The lever, just to pinpoint again, you must understand that the farther your effort, okay, as you're pushing down on the lever, the farther your effort is from the fulcrum, the greater the advantage. Okay, so it's in your best interest that your load is here and the fulcrum is close to the load, so that when you push down, you won't have to exert so much force. Okay, wheel and axle. This is the axle part of the wheel or of the simple machine, and obviously the diameter of the wheel lets you go further distances with very little effort that you are exerting on the pedals, in this particular case of a bicycle. On screws, you will see that there's different types of screws, but you will notice the grooves, the pitches, the threads in each one, and these make fastening tighter. Okay, on the ramps, this is exactly what we're talking about. It's obviously easier to use a ramp than it is to carry this lawnmower or this machine onto the back of the truck with your own force. The pulley, once again, you exert force on this side and the load is being carried. Okay, this rope or this string runs on a groove right here, and because the pulley is a free spinning machine, there's very little friction, if no friction at all. The wedge, once again, the reason you're able to crack the log is because you are using an axe or a mallet to hit this point in, and this diameter is spreading the wood apart. That is a review on our Simple Machines lecture for today. Remember to do your whisk and document any questions you still may have. Thank you for listening. Welcome to class today.